All right, so we all good with number one? Right, so again, each part, make sure you are grading yourself. Either of those answers are okay, and that one was a total of 10 points. All right, number two. Number two, I think I could have been a little better with writing a sentence for my reasons, okay? So I think I could have wrote a better sentence here and here. Okay, so what I chose to do on this one is I went bullet by bullet and I said, okay, vertical asymptote. So I kind of did part B as I went through those bullets. I wish I would have read ahead and I would have written this down here. All right, so vertical asymptotes of x equals 2 and x equals -3. So I'm circling the stuff on how I started. So then horizontal asymptote of -3. So I put in this -3 and I told myself that n had to be equal m. Degree of numerator had to be degree of denominator. That's the only time you're going to get that horizontal asymptote. So then I skipped this one and I said a whole at -1. I need this factor and this factor to create a whole. Zeros at -5 and 4. So that gave me those zeros. So I've got almost everything circled. The output sign changes at -5, but not at 4. So what that means is at -5, it passes through. At 4, it's tangent. So at 4, that gave me the multiplicity of 2, right? That's when the sign's not going to change. Okay, so then I went back to this one. I would have changed writing this a little bit. What is that part missing? What is that part missing? What do you think? Andrew? The plus or minus. So the person that wrote this, maybe they taught it in a way when you don't have the plus or a minus, that is going into calc a little bit. When you don't have the plus or minus, it does really mean both of them. So if you didn't do that on that, that's totally fine. But I did it as both of them, okay? So I took -299, plugged it in and did a sign graph. So it's a negative, a positive. This is squared, so it's a positive and it's a negative. -299 on the bottom. And right now I don't have the square, right? So I plug a negative in there. I plug it in there, it's positive. I plug it in there, it is negative. So right now that result is a positive. So I am okay. So then if I do -301, so this stays negative, -301, that stays positive, that stays positive, that stays negative. So now when I do the bottom, that is a negative. When the square isn't there, that's a negative, and that's a negative. So the result on that one is actually a negative. I did it for both sides. So I needed one of these to change to a square. I think you could have put in any of them to be a square. I just chose this one because that's where I was looking at. So that's why, that's why I included the square there so that that one would turn to a positive. It doesn't change it from the first one because it was already a positive. So that's why I put that extra 2 in there. All right, that's why I put the extra 2 in there. Okay, so that is what I'm trying to have as the function. So it says, what's the minimal possible degree for the numerator of Rx? Give a reason for your answer. So again, I kind of didn't do maybe what a good idea is, right? I think I should have, like, on a paper that wasn't being graded, do little bullets and say, okay, I needed a degree of 4 because at 4, the sign doesn't change, so that needs to be even. And then I have 2 more zeros, right? So I kind of wrote my bullets and didn't write a nice sentence of it. I think, because if you read that sentence, 4, since output sign doesn't change, need even, 2 more 4 zeros. I don't know, it's just not a nice flowing sentence. So I think I should have said minimum degree of the numerator would have been 4, since at the 0 of 4, output sign doesn't change, so exponent wouldn't need to be even, and then there are 2 more zeros. So a minimum of 4. Second one, I think it's fine. Draw a conclusion based upon the degree of numerator and denominator. The degree of the numerator and denominator, and again, I probably should have put of numerator and denominator, needs to be equal due to where the horizontal asymptote is. So if it helps bulleting your reasons and then thinking of a nice complete sentence, do that. So then obviously my answer is right here for that one. So for points on that one, I did 2 points on this one, 1 point on this one, and 2 points on that one. So again, grade yourself, put the correct answer in there if it's not correct. Any issues on that part? So we definitely had some disagreements in the other classes on the bottom part. So bottom part, it says the function t of x is a transformation of r of x with the following transformations applied in this order. On part C, it says write t of x in terms of r of x. So someone in the other class yesterday said, well, do we have to use this whole r of x function? I think that would be really hard to do that. So this is what I think they wanted on that. So again, I did step by step. So y-axis reflection, dilation horizontally by 2, vertical dilation of 3, and then a left 1 and an up 4. So I think this answer or that answer would be fine for that part C. Then in D, it's asking you where the hole moved and where the horizontal asymptote moved. So I said, okay, the hole is originally at -1. If I do it in this order, the things that will change the x value will be the inputs. So I took -1, did a y-axis reflection, came +1. Vertical stretch of 2, got to a +2. And then left 1, got to a 1. So I think that x value of the whole would have moved to 1. And then same thing for the horizontal asymptote, that would have been your outputs. It's originally at -3. You do a vertical stretch of 3, it goes to -9. You go up 4, it goes to -5. So I did 2 points for this one, 1 point, and 1 point. Any issues or any other ways that you guys solved that? Someone in the other class said, well, why is it at 1? Because they took -1 and plugged it in. I think that's the wrong method. I think you have to take -1/2 minus 1/2 x, set it equal to -1, and see where it moved. So if you do that, it does move to +1. So I think they just kind of did that input and output backwards. All right, so go put what you got on number 2. Any questions, guys? 1 or 2? And I think, did I end up putting the answers to this online yesterday? I think I did, right? There are a couple of extra. Oh, look, I found the quiz I was looking for yesterday in my pile. Thought I looked at that pile. There are maybe 2 more blank copies. If anybody wants a blank copy to practice on these, I'll just leave them up here. Okay. Okay. So we're on the third one, number 15. Okay, so this is one that they actually did have an answer key for. So I have no problem in telling you, I didn't match the answer key the first time I did it, right? What do you think I forgot on the very first part, right? I had n greater than or equal to 3 rather than 5. What do you think I forgot? The cube thing, changing concavity, right? So that's what I forgot. So again, I will own that I forgot that. I got it wrong when I first did it, right? Oops, I need the picture. Okay, so it says, portion of the graph is shown. This is something else that somebody else in the other class brought up. They said portion of the function is shown. So how can I really draw a conclusion about the leading coefficient, right? They said there's no arrowheads at the end. So it could really go back up, right? So I think the directions would been a little better if it said a portion of the function with the correct end behavior are shown. I think that's really the only way that you can make some of these assumptions. Would you guys agree with that? Right? Because again, if it's just showing a portion, that end behavior could really change. Okay, so let's see. Numerical value of n, degree of the numerator, right? Yeah, polynomial degree. So you know at this 0, the multiplicity has to be even. You know at this 0, the multiplicity has to be odd and at least 3 because it changes its concavity. This is another one where, again, I wish I would have went back and wrote a nicer sentence. So n has to be greater than or equal to 5. It must be odd due to the n behavior. The 0 on the left has an even multiplicity. The 0 on the right has a change in concavity. So it has to be at least 3, right? So again, I wish I was getting lazy in my explanations. I wish I would have went back and fixed that to a nicer sentence. I think part 2 is easy if we add that end behavior in there, right? So it is a positive a based upon the end behavior. That limit of f of x goes to infinity as x goes to infinity. I think B goes along with A as well. So if we have 13 minus rad 2 and x squared plus 4, I said the degree has to be at least 9 because of the complex conjugate theorem. There has to be a plus and a minus. This is going to give me 2 more imaginary zeros. So I need to be adding 4 to my previous statement. Someone in the other class also added, it should have said that it has integer coefficients because I could just have a 0 of 13 minus rad 2 if they're not integer coefficients. So if you make those assumptions, I think that's what you could add in there. I'm assuming there's integer coefficients, so they have to be conjugates. All right, so on those, I made all of those 2 points each. All right, all of those were 2 points each. I think kind of the top goes together, the bottom goes together. Any issues on those top 3? All right, bottom 3. Those were doing average rates of change. This is where I saw a lot of people using abbreviations, AROC, don't use abbreviations, right? And a lot of people didn't show work as well. So make sure you're showing work. -3, 3. So f of -3, f of 3 over -3 minus 3, average rate of change is 2. So then find B. So if you find B, I take the average rate of change. I use the point at -1 and -3, cross multiply and solved, and found B being 4. When they ask you to find a variable, make sure you're putting B equals 4. When I ask you in the midterm or AP. So now the last part I had to think a little bit, but I think what I did is okay. You guys can tell me if you did something different. So it says it's a quadratic function and it says it's concave up. So if you go back to your chart here, if it's concave up, the rate of change needs to increase. Rate of change needs to increase. So this is how I thought about it. On the left-hand side of that question, I need 12 minus C. So I said if I did the average rate of change there, I'd get 12 minus C. So I did 12 minus C over 3 minus 1. 3 minus 1 is 2. So then the right-hand side of that had a B in it. So I looked at this and I said, okay, if I do the average rate of change for that, I'll have a B in it. So my work is down here, right? So again, I showed my work, average rate of change, I had my 12C. I showed my work, average rate of change, I had the B in it. So I did 3 minus 1 is 2, and -1 minus a -3 is 2. So the denominators were the same. So I was okay with comparing 12 minus C and B, since the average rate of change had to increase. This one had to be bigger than this one. So that's why I chose, did I put greater than somewhere? Yeah. So that's why I chose greater than. I think that part was a hard part on that one. So then I went 2 points, 2 points, 2 points. So again, I just changed their point values a little bit. I think that one was a good one now. Bailey, do you have a question or? Okay, I thought that was a hand. Any questions on number 3? All right, so now last one. Last one, I totally messed up the equation on the bottom when I first did it, okay? All right, so these are doing what? Inverses, compositions. So first couple, I don't think were bad at all, right? So, and again, showing work. G of 4 is 1, and then F of -1 is 4. Part B, take H of X and solve it for all the variables. So I plugged 1 in, I changed forms, and I solved for X being 1/3. Part C, the data in the table, does it support that it's exponential or logarithmic? I put, since the rate of change of the inputs are proportional, it has to be logarithmic. So when the inputs are proportional, it's logarithmic. When the outputs are proportional, it's exponential, right? Inputs versus outputs. And I should put over equal intervals of the outputs. I should put that. I did not. So those I didn't think, oh, and the D I didn't think was that bad. I just plugged in X to the 4th. I need to put it in this form. So I did the product property and then simplified. Again, they're asking for A and D. So make sure you're putting A is 4, D is 2. So I did 1 point, 1 point, 1 point. I did 3 points for that, but after I thought about it, it probably should have been like 2 points. Well, maybe 3, 1 for A, 1 for D, 1 for work. Okay, are those okay? All right, so now this is the one that I got wrong on this the first time I did it. And when I did the answers, so this is my wrong answer, right? I put the right answer up online. I knew I was wrong. Why? Why does that tell me that that exponential is wrong? Say it again. So it's got the wrong graph, and I didn't think of that. The base, this base is negative, doesn't make sense for any exponential, right? An exponential can't have a base to be a negative, because remember, it goes point above, gap, point below, gap, point above, gap, right? Because my exponent couldn't be a half. I didn't even think about that when I did this, right? So online is my correct answer, but I will do it for you, right? So what I did is I said, okay, in an inverse, this point will become 0, -1. In an inverse, this point becomes 1, 4. In an inverse, this vertical asymptote at -2 becomes a horizontal asymptote. So I've got an exponential function. So then again, my work online is correct. So I said, okay, I have the inverse. It is exponential. I have these 2 points. So if you think about an exponential, it's in that form. But I know it's down 2 by my horizontal asymptote. So I started with that. Then I plugged my initial point in. X is 0 when A is -1. So I added 2 to both sides and got A being 1. So then my next step, A is 1. I plugged in the point 4, 1. Brought the 2 over. Whoops, I plugged in the wrong spot. Brought the 2 over and got B being 6. So my final answer was A is 1, B is 6, and I have 6x minus 6 to the x minus 2. So that made much more, but again, I didn't pick up on that when I did it out. I only picked up on it the first time I did it in class. That one was 2 points. So Evan's question is where the -2 comes from. Because it has a vertical at -2, it's got to have a horizontal at -2. And that's the part that I missed when I first did it, right? When I first did it, I just said, okay, a log has to be an exponential, and I started with that, and I got the negative form. I'm like, oh, it works, the points plug in. But no, it didn't work, okay? So that last one was 2 points. So same deal, you're gonna grade yourself, you're gonna put it in number 3 and number 4, and then you're gonna give yourself a percentage. Give yourself a percentage. So Faith did take the last 2, no big deal though, right? Because there is the blank ones online, right? But again, you don't have to print it. You utilize what I already copied. All right, so give yourself a percentage on that little piece of paper, please. Give yourself a percentage. I want those papers.